Hi guys, this is a follow-up video of the development of kidneys video, and in this we're going to talk about the anomalies. Along with the anomalies for the kidney, we're going to talk about a few that are given in the first year related to the ureter and the bladder. So I'm going to quickly also discuss the development of that because it's very short. A part of the development of the urinary bladder I've already discussed in the last video with the allantois. The rest we're going to talk about in this. So just let's go with the anomalies of kidneys first. So basically these are the basics. Either they may be absent, agenesis, underdeveloped, hyperplasia, overdeveloped, hyperplasia, or adrenal tissue can be there in the kidney substance. Next is distension of the pelvis with urine. This is actually very important to know the term hydronephrosis. That means water in the kidney, more specifically the pelvis region. And why does it occur? Obviously there's an obstruction at some point, that's why urine is accumulating. Last is duplication. That means there are two kidneys, two can be two on each side, you could say, extra kidney on one side, separate, fused, whatever. Next we talk about the anomalies of shape, in which we have a pancake kidney where the two kidneys are fused like this, they look like a pancake. We could have a lobulated kidney like that, so the shape is not exactly bean shaped, it's irregular. And the third most important is the horseshoe kidney, so it could be like this or like this, but this is not that common. Most common is that the inferior or the lower poles are fused. Okay, so they lie in front or behind of the aorta and the IVC. Inferior vena cava is somewhat here. Okay, so what happens is from the abdominal aorta, the IMA or the inferior mesenteric artery arises. Like I'm showing it laterally, but it arises from the front. This is the aorta, this is the IVC. So what happens is, now this is the IVC, this is the IMA, inferior mesenteric artery, and this is the horseshoe shaped kidney. It cannot ascend normally, it gets stuck here. So this is an example of abnormality of shape as well as position, because the kidneys are not able to ascend to its normal location. So that's horseshoe kidney. So because of the IMA, which is preventing the ascent. Now the ascent of kidney can also go wrong. That is the last step we discussed in that video. What happens is then the anomalies of position happens. Totally agar ascent nahi hua, then the kidneys will be in the sacral region. If it is incomplete, then lower lumbar region. If they ascend too far, they may end up in the thoracic cavity, or otherwise both of them can be on one side of the midline. It's not duplicate kidney, there are only two kidneys, but both of them are one side of the kidney. They're either beside each other or on top of each other, somewhat like that, and even this can occur. So that is about the anomalies of position. Now abnormal rotation. So along with the rotation of the stomach and the midgut, the kidney also rotates, but it's not that important. The only thing is, if it's abnormal, the hilum will not be directed at the normal position, like that is medially. It will be forward, anterolateral, or anteromedial. Okay, now congenital polycystic kidney I will discuss when I discuss it in the first state, that is multicystic dysplastic kidney. Thus is aberrant renal arteries. Again, this is not as important. There's a lot of other anomalies. So what happens is, we're gonna see if the kidneys are actually first developing in the sacral region. Assume both of them are of the same size, and then they ascend upwards to the normal position, the upper lumbar position. All right, so while they are doing that, what happens is their blood supply keeps changing. From here it will be something else, and finally at the end, development is over, they are supplied by the renal arteries. So what happens is, aberrant renal arteries, because of the ascent being abnormal, okay, non-ascent or incomplete ascent, aberrant arteries may constitute the only supply to the organ. Okay, so instead of the renal arteries, another artery can supply the kidneys. So this can lead to obstruction of the ureters also, that can cause hydronephrosis. So this aberrant renal arteries ka case you can also see in horseshoe kidney, because even there ascent of kidney is also affected. So we'll see about that. So that is all that is mentioned in IBC. Okay, so before I go into discussing first aid, quickly we're going to talk about development of the ureters and the bladder. So ureters में Or you obviously know the mesenteric duct from where the ureteric bud arises. The ureteric bud goes to the metanephric mesenchyme, leading to development of the kidney. So what happens is, this is how the bladder is. The mesonephric ducts start getting absorbed inside. So what happens is, progressive absorption will lead to this point reaching here. So it will become somewhat like that. Alright, so this is how it initially is. The two ureteric bud opening, the mesonephric ducts opening. But what happens is, imagine this is how the ureters are, right? So imagine they get absorbed even more. Okay, so this point will end up like here. Okay, so they're more far apart. So what happens is, this becomes like that. The ureteric buds or the opening of the ureters are far apart, and the mesonephric ducts, they are closely here, and between these forms a triangular region which is called as a trigone of the bladder. And because this part is formed due to absorption of the mesonephric duct, this is mesodermal in origin. The urinary bladder actually is coming from the gut, right, hind gut, but that's why it's endodermal, but this part is mesodermal. So that is about the development of the urinary bladder. The rest part of the urinary bladder, we talk about the cloaca, we talk about the urorectal septum, vesicoureteral canal, allantois, all of that I have discussed in the previous video. After that, what happens is the absorption of the mesonephric ducts in the ureter, and we get the adult bladder. So now we talk about anomalies related. So this is what we discussed in the previous video, so that's why I added that picture. Okay, so talking about the first stage. So first is the horseshoe kidney. Inferior poles fused, they ascend, they get trapped under inferior mesenteric artery, remain low. They can be associated with hydronephrosis. As I said, it could be related to the aberrant renal arteries, or there could be an obstruction, anything, and can lead to this hydronephrosis. Renal stones, infection, increased risk of renal gas, all these are secondary. What is important to know that horseshoe kidney ka incidence is higher in chromosomal aneuploidy, either Turner syndrome, which is XO, or trisomies of 13, 18, and 21, that is Edwards, Patau, and Downs, or I think it's Patau's, Edwards, and Down. Just cross check 13 and 18, always confusing. So that was about the horseshoe kidney. Congenital solitary functioning kidney. This is where only one kidney is functioning, the other kidney has degenerated or not developed. Okay, so most what happens is, because of the only one functioning kidney, the compensatory action is the hypertrophy of the contralateral kidney. Okay, so the two things can happen: unilateral renal agenesis, that means ureteric bud does not develop, so it does not cause any differentiation, so there is no kidney, there is no ureter on one side. Or there could be a multicystic dysplastic kidney, that means the ureteric bud develops, it may or may not come in contact with the metanephric mesenchyme, but it fails to induce differentiation. So what happens is, there cysts form. So whatever normal kidney is there, the cysts bother the normal kidney tissue also, and there's a multicystic, or you can say polycystic dysplastic kidney, which is non-functional, consisting of cysts and connective tissue. So this is non-hereditary. Here we saw it is associated with aneuploidy. Here it is non-hereditary, usually unilateral. So bilateral leads to Potter sequence. So Potter sequence is a pathology that happens, or one of the reasons for its occurrence is renal impairment. So obviously, if there's bilateral multicystic dysplastic kidney, means both the kidneys are non-functional, obviously there will be renal impairment. That's why we'll see Potter sequence. Now these three are related to the ureters and the bladder. First is in the duplex collecting system. So now the ureteric bud, for example, before entering the metanephric blastema, it bifurcates, and here is your metanephric blastema. So when it comes in contact with your metanephric blastema, it will cause the development of one collecting system here and one collecting system here. We have two pelvis and basically duplex collecting system for urine. So that is what happens here. Y-shaped bifid ureter. So again, there are other stuff related to that, not that important, but we'll see. Vesicoureteral reflex, ureteral obstruction, increased risk for UTIs. So in duplex collecting system and in vesicoureteral reflex, you'll see UTIs because of the abnormal passage of the urine. Okay, it will result to the UTIs. And vesicoureteral reflux and ureteral obstruction also seen, again not that important, just we can say it's an anomaly duplex system. This is actually a little more important because it's the most common cause of bladder outlet obstruction in male infants. What happens is, while this is getting absorbed, a membrane remnant is persistent in the prostatic urethra in males. So that obstruction will obviously cause hydronephrosis, and other symptoms are that we see here in posterior urethral valves which are persistent. Here you see the valve is persistent, so there will be a distended bladder. The bladder wall will be hypertrophied. Here you see it is not hypertrophied. Then the urinary reflux will be there. There will be distension of the ureter and the pelvis because of the accumulation of the urine. So there will be hydronephrosis and hydroureter. So all these symptoms will be seen in posterior urethral valve. When you see prenatally also, all these can be diagnosed. Severe obstruction will lead to oligohydramnios. So that very important. Please remember, oligohydramnios. Hydramnios का reason can also be posterior urethral valves. Okay. Last is, from the bladder the urine is flowing in a retrograde direction back to the ureter. Two reasons हो सकते हैं. Either when this ureteric bud is getting absorbed, it is insufficiently absorbed, insufficiently insertion of the ureter, so that's why there is a retrograde flow, or the bladder pressure is only high, that means it's leading to retrograde flow. So this abnormal flow of urine obviously can lead to increased risk of recurrent UTIs. So that's all for this video. I hope you found it useful, and I'll see you guys in my next one. Bye.